So, welcome you all again. This is a whole new video series about the differential equations. Under differential equations, if there is sounds, please know them because there is some kind of a festival is going on here. Under differential equations, there are mainly two things: ordinary differential equations and partial differential equations. Ordinary differential equations simply means that there is only one single independent variable. In partial differential equations, there are several independent variables. So we are to talk about the ordinary differential equations. Under ordinary differential equations, I'm going to form the fundamentals step by step. So first we are going to talk about first order differential equations. First order differential equations means that the highest derivative is 1. Okay, there is no like this term. So the highest derivative is this dy over dx. So f dash x, this the highest derivative is 1. So it is we call the first order differential equations. So under first order differential equations, we are going to first solve the variable separable equations. So they are the most fundamental type and the most easiest way to solve the most easiest kind of differential equations. So let's get started. So the structure of the variable separable method is you have equation like dy over dx is equal to fx times gy. So what is variable separable method is you can always separate the variables, independent and dependent variable, into the different side of the equal sign. Here you can see there is equal sign here, so I can take gy here is like 1 over gy. Dy is equal, I push dx to the next side, so it is like fx dx. So you can see dx is with the x variables and dy is with the gy. So if you can reduce the equation to this model, we call it a variable separable. So again, if you can write the equation like this, it's a variable separable. And how to solve it? How to solve it is we simply integrate the both of sides. So it's 1 over gy dy, integrate both of sides to the fx dx. So now we solve it. So that's how we're going to solve it. So now let's do some simple questions. At the end of this video, we talk about some actually, even though this is the most fundamental method, there are many applications in physics and engineering with this simple method. So let's do the question. So questions, I put the questions, all the questions in the description if I can. The first question is dy over dx is equal to d e to the 2x plus y. So you know, since this is some kind of exponent, we can explain this expression like e to the power 2x times e to the power y by using the mathematical rules of exponents. Now we can bring dy to the downside, so e to the power minus y dy is equal to the e to the power 2x dx. So we integrate the both of the sides. If we integrate e to the power minus 1, it's e to the power minus 1 over minus 1 equals e to the power 2x over 2 plus, see there is always a const if you integrate it. So this sides also have a const, but with that const and this const, I can simply write one const there. So this is the answer for this solution. I hope you know the basic integrations. Yeah, let's move to the second question. The second question is dy over dx is equal to be xy over x plus 1. So simply it's easy. You can bring this y into the left side. So it is 1 over y dy is equal to x over x plus 1 dx. So now we can just integrate both of the sides. If you integrate 1 over y, it's ln y is equal. If you want to integrate this, you can rewrite this like so x plus 1. I can write x plus 1 minus 1 over x plus 1. So it's simply 1 minus 1 over 1 x plus 1. So these two are same. So I can rewrite like this 1 minus 1 over x plus 1 dx. So if you integrate it, it is equal to the x minus 1 over x plus 1. If you integrate it, it's ln x plus 1 plus c. So the final answer would be ln y is equal to x minus ln x plus 1 plus c. So this is the solution. So I hope you know the basic integrals. Sorry for the noise actually. There is some firecrackers going on with some kind of festival here. So I think you know the basic integrals, because if the denominator, the if you differentiate the denominator here, if you differentiate the denominator, it's 1. It is in the numerator. So if so, you can use ln directly. Here is also the same. That is why the differentiation is on the numerator. So if the differentiation of the denominator is on the numerator, you can just use ln y. If it is not, you have to use another method. So let's move to the next question. These are very easy questions. So it is 2y dx times 3x squared dy is equal to 0. I can simply write this as 2y dx is equal to minus 2x squared dy, and you can separate variables. I kept 2 over 3 here. I don't care about it if they are constant, so I place here is equal to 3. Maybe I put minus is also here. So it is just 1 over y dy. So I keep minus 1, 2 over 3 here. So if I differentiate, integrate the both of the sides, I can get what is the differentiation of x to the power minus 2. It's like xn plus 1 over n plus 1. So if there's something called xn, the differentiation of is xn plus 1 over n plus 1. So if you use that rule, it is 1 over x times minus 1 is equal to, this is ln y plus c. So the solution is 2 over 3 x is equal to ln y plus c. So this is the solution. So these are really easy questions. This is also a really easy one. I could try the next one. I skip the next one. You guys can try it. It is really easy. Equal to minus 2x can do well. So how to solve this? This is also variable separable, so you can bring this minus 2x here. 1 over minus 2, 1 over x. Oh, sorry. So x should be here. Y is the one should be doing out here, because you cannot do anything with 1 over dx, okay? So dx will be always in the numerator. So 1 over tan 2y is equal, dy is equal to minus 2x dx. So you want to integrate the bottom sides. So what is the integration of 1 over tan 2y? So in this tan and cot integrations, it is really easy, because if you see 1 over tan to y, it is just cot to y, and we can write cot to y like cos 2y over sine 2y. In the earlier I asked you, I tell you the differentiation of the denominator. What is the differentiation of sine 2y? It is just cos 2y times 2. Okay, if we multiply 2 divide by 2, we consider and this part the differentiation of the denominator is in the numerator, so we can easily write it using ln. So the differentiation integration of this 1 over tan 2y is just 1 half. We can put const, no problem, just ln sine 2y is equal to minus 2. To integrate x, it's x squared over 2 plus c. So yeah, now the final solution is 1 over 2 ln sine 2y is equal to the minus x squared plus c. So this is the final answer. So now let's move to the most interesting part of this. The next few questions are the equations. In some questions the equation are not directly given, so we have to derive an equation using some kind of other theorems. So let's start it. So the next question is, cars are attached to a giant wheel on a fairground ride, and they can be made to lower or rise height. The wheel is turning around. Let the height of the background of such car be h meters. Let t be the time in seconds. Since the ride starts, it may be assumed that the h statics the differential equation. So the differential equation is given. So now what is the incident is going on here? So the scenario is explaining about a giant wheel. There is a giant wheel, something like this, and in a giant wheel there is some small kind of, like, let's say a car. So you can imagine some kind of I think there is a thing like this in some kind of carnivals. There is a giant wheel and it rotates, and when it is rotating you are on this kind of, you can say, bucket. So this problem is like saying like car, so you can say bucket. And the bucket it can be moved up or down with the moving of this bigger wheel. So at the time says uh, at the time this is h8 from the ground, and in the time t, so they model the dh over dt. So the rate of change in the height is equal to the 3 over 2 times square root of h sine 3t over 4. So this is given. So actually it makes sense, that sine can be varied between -1 to +1. So even though it is can be minus, here the height cannot be minus, so we'll see. And it is given that at the t is equal 0, the h is equal 1. So this is now initial value problem. So we can fully solve even this constant. Early example there is always a constant. We cannot solve it until initial condition is given. So in this question the initial condition is given so that we can solve the equation fully. So yeah, let's begin. This is easy. You can directly see that the variables can be separate. So I take h variables into the left side. So it's h minus 1 half dh is equal to 3 over 2 times sine 3t over 4 times dt. So I integrate the both of the sides. So again, this is like h to the power n integration. So what is that? H to the power n plus 1 over n plus 1. So here is add the plus 1 here, it could be plus 1 half over 1 half means 2 here. So it is equal to the integration of sine. What is the integration of sine t actually? Integration of sine kt. Integration of sine kt is just minus cos 3t over 4 over 3 over 4 over 3 over 4 plus. See, there is a const always. So if we write this, it is the 2 times square root of h is equal to the 3 minus 3 over 2 cos 3t over 4 over 3 over 4 means 4 come to the above. See, this 2 is cancelling out to this 2. This minus 2 is cancelling out. So after fully solve this is like this, so you can divide the whole question by 2 each. So and bring the cos term to the left side. Cos 20 of plus c dash is equal to 0. So this is not the same const because I divided the whole question 2 and get c to the left side. So this is the differential. So we'll solve it. So now our initial condition is given. H is equal to 0. So t is equal to 0. H is equal 1. So when t is equal to 0, this becomes cos 0. Cos 0 is equal to 1. So square root of 1 is 1. So 1 plus 1 is 2. So c dash is simply minus 2. So the answer for the question is square root h plus cos 3t over 4 minus 2 is equal to 0. So this is the solution. So it makes sense because you can see that since that square root of h is equal to minus cos 3t over 4, right? So the cos can be varying with minus 1 and plus 1. Okay, minus 1 and plus 1. Even though in this is cos term become minus 1, or cos this become plus 1, the whole term stays as a positive value. So since 2 minus 1 is equal to 1. So what is the mean is it is minimally it can be go down to the 1. I don't know. Yeah, when we're looking at the equation, that's what we can say. So the solution is making sense. So let's move to the next question. So in the next question, they are telling that the computer processor is initially at a temperature of 90 Celsius. So this is an initial value problem. So when time is at 0, the temperature is 90 Celsius. It is placed in a room where the ambient temperature is 25 Celsius. The rate of which is the processor is cooled is proportional to the rate of cooling. So that means we say that, so first we understand the situation. There is a chip here. So here there is a chip. So this is at a temperature T1 we say, or we say T0, at a temperature T0. Since the outer environment is more cooler than that, the heat is dissipated. And the question said the rate which is the processor is cools is proportional to the difference between its temperature and the surrounding temperature. So the heat is goes on, so heat is dissipated. So the rate which heat is dissipated is proportional to the rate is the difference between its temperature and the surrounding temperature. Its temperature and the surrounding temperature. We say TR to see the room temperature. So the question asks after 5 minutes, then it also says that after 5 minutes, when T is equal to 5, the temperature drops to 16 Celsius. And what they ask is solve the differential equation and estimate the temperature after 10 minutes. So to get rid of this proportional mark, we should add an const. So it is T minus TR. ATR is also const. We know it is 25. So this is actually a very famous physics theorem. We call it the Newton's Newton's cooling law. The rate of change in the temperature is proportional to the difference between its temperature and the surrounding temperature. So there is many conditions to apply this, but here the question gave it. So yeah, we have it. So another question is, since it is decreasing, this dt over dt, that means rate of change is always a minus value. So if you think that this k is a positive value, we should add a minus sign to here. So we have our freedom to add the const here. So we make this k is positive, so we should add a minus sign to be before it, since this dt over dt is always a negative value. It is a decreasing. It's always decreasing. So let's solve this. This is really easy. Okay, so we can now argue that why there is two conditions are given, because there is a new kind of variable is there. To find it, we need another condition. So yeah. So let's solve this. This is really easy. So 1 over t minus 25 dt is equal to the minus k dt. We can integrate the both sides. So if we integrate this is just ln t minus 25 is equal to the minus k t plus c. So this is we solve the differential equation. Now we have two conditions. Now we apply those two conditions and write the equation again. So they say at t is equal to 0, the temperature is 90. So t is equal to 0, temperature 90 minus 25 is equal to minus k times 0 is 0, c. So we can directly find c. It is ln let's write in here, equal to 6 ln 65. It's a positive value like this. So if you're confused why I put always this modulus value, because ln is a positive, for the negative values ln is not defined. So the values inside the ln should be always given positive value. So That is why logic confuse it. Since this is a real world question, this is always positive values coming to these inside alien values. So we find C. So now we're going to find K. So when T is equal to 5, the temperature is given as 60. So Ln 60 minus 25 is equal to the minus K times 5 plus C. Now C is equal also Ln 65. So Ln is 35 minus Ln 65 is equal minus K times 5. So it is really easy when it's come to subtraction of logarithms. You can just write this as Ln 35 over 65. It is equal to the, again guys, sorry for the noise. There's some kind of festivals and then some kids playing around. They're enjoying, I guess. So K is equal to minus 1 over 5 Ln. We divide both of the sides with 5. This is 7 and 13. So 7 over 13. So fine, we find C and K. The final solution for this scenario is Ln T minus 25 is equal to plus K. K. So K is equal to some kind of minus. Okay. So minus KT. Minus KT means 1 over 5 Ln 7 over 13 plus C means Ln 65. So this is the final solution to the equation. So you wonder that how K is always a positive value. So here Ln 7 over 13 means it is always less than 1. It is always less than 1. So if you look at the Ln curve, it is something like this, I guess. Let me try it. So yeah guys, the Ln curve is something like this. So it is 1 is here, 1 is here. So less than 1, it is always negative value. So negative become positive. So the K is always a positive value. So finally what they ask is the after 10 minutes. So after 10 minutes means, sorry, there's a T. So you put T is equal to 10 and you find the value. So let's do that. So then Ln T minus 25 is equal to the 1 over 5 Ln 7 over 13 times T is equal to 10 plus Ln 65. So with calculator you can solve this. So if you go ahead and solve it, you get T is equal to 43.8 Celsius. So it is possible, okay. At 5 minutes it's like 60. At 10 minutes it's like 43.8. And I remember to tell you that you can further simplify this solution here. You can further simplify this equation here, because these all are in Ln terms. So you can write Ln T minus 25 is equal to the Ln there is a two ln terms together. If you put this 1 over 5, you put this 1 over 5 and this t inside this ln, what you get is ln 7 over 13 to the power 3 over 5. Isn't it, guys? Because if there is some constant in the front of the ln, you can bring it as a power times ln 65. So this becomes ln t minus 25 is become ln 7 over 13 to the power 3 over 5 plus 65. If we compare this term and this term here, it is like t is equal to the 7 over 13 sorry, if there is a plus here, it will be a multiplication here. 3 over 5 times 65 minus 25. So that is the final equation. So if you are in high school and you see there is some kind of Newton's cooling law, which you should have learned. So if you draw the graph, t is equal 7 over 13 t over 5 65 minus 25, what you will get. Let me show you. So yeah, this is positive and this is minus 25, it's going to this side, so it becomes plus 25. If you plot this graph, what you actually get is this. So I use decimals, what you get is this. Okay, if you look at the famous Newton's cooling curve, it is like this. Okay, so you can see how this is, this graph is mainly drawn using the experimental value. You some time t, you measure the temperature. So if there is another graph, this is time as is the temperature. So yeah, you can see it is the same as what we get from the mathematical curve. So in this like t minus 25, that means the extra temperature. If you plot the extra temperature, this it will be like this. So it is just the same thing that you can see. You get the experimental graph. So mathematically it is proven that this curve is something like this. This curve is something like this. This is exact as Newton's cooling law. So what Newton did is he invented this equation. Okay. So by an experiment data, making this equation is some kind of a good work. Okay, it is not really easy. So let's move to the next question then. So the next question says a charged capacitor is connected to across a resistor. So that's a charged capacitor is connected across a resistor, forming a simple RC circuit. This simple RC circuit. There is a capacitor. The voltage across the capacitor decreases over time. Yes, you can see there is if there is a switch and a battery here. If we close the switch, the current is going on here. Since this is a DC circuit, there is a zero current. We can see that there is a zero current because to flow a current through a capacitor, it will be some kind of alternative current. Since this is a DC current, there is no current flowing. So, but the capacitor is charged. So when we open the circuit, what has happened is the capacitor is discharged through this resistor. The voltage across the capacitor decreases over time such the rate of change of voltage is proportional to the voltage itself. So it says the rate of change of voltage is the rate of change of voltage is proportional to the voltage itself. So since we know that, so we should add const to this to get the equation. So before putting this minus const here, you should do experiment and find there is no other things that other variables that are not affecting this this DODT. If you do, actually in the real situation there is no other things, only the initial voltage. You get this equation. Since this is decreasing, you should put the minus value inside in front of this k. So now this is really easy to solve. So it's 1 over v, dv is equal to 1 over k dt. When you replace the corner sides, you can get ln v is equal to minus k t plus c. So if you get rid of this ln value, we can see that v is equal to what? V to the power minus k t plus c. If you bring that e to the power c, you can write this as e to the minus k t times e to the power c. This is a const, so we can say v is equal to c dash times e to the minus kt. So this is the equation. We solved it. So we are given initial conditions as when the t is equal to 0, the voltage difference is 12. So if we apply it, 12 is equal to c dash e to the 0. This is 1. So what it implies c dash is equal to 12. So we are done. V is equal to 12 times e to the minus kt. So for find k, there is another initial condition is given in the question. If you don't remember it, go back and go ahead and check the question. It is given as at the t is equal to voltage is equal to the 4. So 4 is equal 12 times e to the minus k 2t. 2t. So minus 2. So if you use 12 to here, it's 1 over 3 is equal to e to the minus 2t. So if you get both of the sign ln 1 over 3 is equal to the minus 2t. So if you get 3 to the numerator, minus value, and get 3 into the numerator is equal to minus 2t. Minus and minus and final out. So it's 1 over 2 ln 3 is equal to the this is a big k. Minus 2k, boy. Okay. 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 So you find k, so you're set. So final equation is 12 times e to the minus k means what? K means K means ln root 3. This half can be put inside this 3. So you see that so many basic things we use here to simplify. Times t times t. So e to the ln something. So again, this t also can be put inside the ln value. So this minus value also put inside the value. So this again 12 e to the ln 1 over root 3 to the power t. So if you simplify it, what you get is 12 1 over root 3 to the power t. Simplify what is get 3 minus t over 2. So this is the final solution. So I hope you are fine with the basic simplifications that I have done here. So if you confused with this step here, how this here is coming, it is like just like this. You can think that if there is some value called k is equal to the e to the ln we say ln x, or we don't care what is inside this ln x. So if we take the both ln from the both side, it is ln e to the ln x. Okay, so 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 ln k is equal to the, so in the ln this power value can be get out of the ln, so it is ln x times ln e. So ln is equal to 1, so k is equal to x. So what does that mean is, if there is a value something like a to the power ln x, it is same as x. So that is what we do here, e to the power ln some value here, so we can directly use that value as the answer for this whole thing. So it is just a simple algebra we use. So the question, what the question asks is, at time is equal to the no, it asks when voltage is equal to 1, what time it take. So we put 1 to the v, it is 12 times t to the minus t over 2. So if you simplify this, you will get 4.52 seconds. Okay, so this is a very interesting solution where the physics, you can solve many physics problems using this variable separable method. Even though this is really easy method in differential equation, it is many applications in this like problems. So what we do is, there is always voltage across this capacitor. So when the circuit is open, the charge voltage is dissipating, so voltage is decreasing. So if you look at the graph, you get here, if you draw it, it is like e to the I cannot think of graph. It is like a decreasing graph. So it is the same as maybe in your classes, in physics classes, you get maybe things you would memorize, how the voltage across a capacitor is dissipating. So that curve is coming from this kind of equations. So this is actually into this condition, because after we apply initial conditions, we got this equation. So yeah. So the next question is population growth with limiting factor. So this is like an engineering modeling. A population of microorganisms. Population of microorganisms grows in such a way that the rate of growing is proportional to both of the current population and the remaining capacity of the environment. So let's try to get our equation. So you say that the growth of microorganisms. So they are growing up in some kind of way. So growing up these microorganisms. Let's say what is growing. Let's say at this time there is n microorganisms. DNO dt is changing the changing how much microorganisms are there. So the population microorganism grows in such a way that the rate of growth, so this rate of growth is proportional to the both current population. Current population is n, and the current population and the remaining capacity of the environment. So and the remaining item. So remaining, we said that the total number of microorganisms can be the initially there is n. The total number of possible microorganisms is capital N minus n. So in the question it is given as n as 1000 because at maximum in the maximum only 1000 organisms can be live here. So dt we put an equal mark and position a const n times, since that is given as 1000 minus n. So yeah, this is really fine. So we get our differential equation. So dno dt is positive because this is a growing scenario. So we can take k as positive, and there's no need of negative mark. I take it because in early equations, in both scenario we got uh, decreasing values. So how to solve this? This is really easy. So we take variables with n to the left side, 1000 minus n, dn is equal to k times dt. So to solve this, so we integrate both of the sides. Now it is always about solving this uh, integration. So the best way to solve this is partial fractions. We can write 1 over n times 1000 minus n as some kind of const over n plus some kind of const over 10 to the power 3 minus n. So we're going to find a and b. So 1 is equal to n plus bn. So if we consider the n to the power 1 power, there is no one in the left, so 0 is equal to b minus a. 0 is equal to b minus a. And if we consider const value, the both of sides, 1 is equal to a to the power a times 10 to the power 3. So 10 to the power minus 3 is equal to a. So that will imply b is equal to also 10 to the power minus 3. So that was some rough work. So we can write this as 10 to the power minus 3 over n plus 10 to the power minus 3 over 10 to the power 3 minus n. That's really simple. If you differentiate this, integrate this term, you get p here. The k is just a const plus c. I will put a const mark at the end by connecting all the constants, so there is no problem with it. And if I integrate this, 10 to the power minus 3 is just a const. Sorry, there is a d in here. There is a d in here. So you know that when there is addition, we can use laws of integration. We can integrate these two terms separately. So I directly integrate and put it. So if I integrate this term in here, it is ln n times 10 to the power minus 3 ln 10 to the power 3 minus n over minus 1. I guess you know because why I put a minus 1 here, because there is a minus in here. So we should always divide by the differentiation inside this ln value. Is equal to the k times t. So if we multiply the whole question by 10 to the power 3, what we get is ln n plus ln. If I place this minus 1 inside this ln, what I got is 1 over 10 to the power 3 minus n is equal to the 10 to the power 3 kt. So I will, these all are const, so I will place a new const as this, putting together these two terms, and I can further simplify these two terms here. It is like ln n over 10 to the power 3 minus n is equal to the k dash t. So yeah, that is our final solution, final equation, and there is a const here. Okay, you remember when this integrating, there should be a const here. Yeah, it will no problem if even though we multiply all the equation by 10 to the power 3. So the const is here. This const is the const that come with the integration, and this const is just, you see, it came with this k value here. This k is come with the removal of this proportional mark. So yeah. So to solve, uh, actually we already solved the equation, so this is the answer. To simplify this more further, we can write n over 10 to the power 3 minus n as e to the power k dash t plus c, and we can rewrite this uh, n is equal to the 10 to the power 3 e to the k dash t plus c minus n e to the k dash t plus c. So if we bring this n to this side, and 1 plus e to the k dash t plus c is equal to the 10 to the power 3. If we further simplify this term, e to the power c times e to the power k dash t, you can do the same thing to here. So n could be, rewrite e to the power c is a const, so we can place a new const here, c dash e to the power k dash t over 1 plus c dash is the same const as this, so we get e to the power c as c dash e to the k dash t. So this is the final solution. So if we given some kind of a t, we can directly say how many uh, microorganisms in that each time. So this is a good example of kind of mathematical uh, modeling. So another observation that you can see here is what happens if the t goes to infinity? If t goes to infinity, you know that et curve is something like this. Ex curve. So ex curve is something like this. It grows exponentially. So it's a 0 is 1 value. So when the t goes to infinity, e to the power k dash t goes to the infinity. So the denominator here is go to the infinity. Will become the what it asks is when the time is grows, its denominator is become really high. When the denominator becomes high, uh, the value. Oh, actually, to see that result, we should further simplify this. It is if you simplify the numerator and denominator with e to the power kt, what we have is 1 over e to the power kt, k dash t plus 1. Okay, plus 1. So, uh, or maybe divide this numerator and denominator with whole this c dash e to the k dash c. Okay, if we do that, what we left with is in the denominator there is 10 to the power c. In the numerator 1 over c dash e to the k dash t plus 1. So now what happens? So when the time is grows and it's really high, infinity, this term here is really big. It's like infinity. So whole term is going to be infinity. That means a very large number. So 1 over really large number is always a really small number. That means mathematically you prove that when this term goes to infinity, 1 over infinity is 0. So 0 plus 1 is 1. So when this t goes to the infinity, n is become 1000. So that was as given in the question. So that is we came up with a really successful answer. Okay, when the time is goes this uh, uh, that's the maximum number of organisms can live there. You know, it happens because there is resources to live there. So when you're out of resources, you're done. So that is the more maximum organisms that can live there. So the next question, it says a tank contains 100 liters. Can contain 100 liters. Let's say capital N. Initially, water draining out through a small hole at the bottom. At the bottom, there is a small hole, and the water is draining out of it. Small hole at the bottom. The rate which water leaves the tank is proportional. You know, there is, let's say, initially, this is initial N, no, we say that it is N naught. So N is the initial liters or the volume inside the tank. So rate of change in volume, water volume, leaves the tank is proportional to the amount of water remaining in the tank. So that's make possible. Okay, if there is more water is draining off to if there is more water, more and more water, the rate of draining is speed. That make possible. Okay, if there is a more height, you can apply some kind of Bernoulli equation here. Then when there is a higher height, the high potential, the water speed draining out of here is coming high. So the volume is just area times, if this area is A, area times the speed. So more water means more speed. More speed means more volume per second is releasing. So this is a differential equation we just solve for the same as like this. This is exactly same like this. So you guys have learned something. Please solve this equation, and in the tag there is also a initial condition and another condition. Two conditions are given because there is when we make our equation, there is another k come here, so we have two constant, this k and the integral, and the constant come with the integral when after solving the integral. So to solve these two constant, there is two conditions are given, and solve for them, and please comment your answer. So thank you very much. In the next video we're going to talk about the uh, another method of solving ordinary differential equations. This is the most fundamental method, but in future we're going to talk about some more complex methods of solving solving more complex differential equation. So thank you for watching.